We talked about this last time, but I want to remind you this time again. We get to working those, and we can split square root of 64x to the 6th. We can split that up and get a simplified version there. Yeah. 8x to the third, because we divide variable to a power, you square root it by dividing it by 2, right? So we get 8x to the third. However, there are some things you can't split apart. Remember what we talked about last time? We can't split apart. Addition and subtraction, yeah. If this was square root of x squared plus 9, it's very tempting there to split that apart. But can we do it? No. Can't split that apart. Can't simplify that because, yeah, the difference is this one's times, this one's plus. Times you can split apart, plus or sum you can't, okay? And I went through an example last time showing you that it just doesn't work. The numbers just don't work out for a sum. And then what about this one? Can I split it apart? What if it was x to the 14th divided by 49? I can split that one apart. Square root of 14 over square root of 49. X to the 7th here, divide the power by 2 here. Just square root of 49, you get 7. Yeah. That's another one you can split apart. Divide. What about this one? Can't simplify that one either. Okay. So just wanted to remind you, there is some limits here to what we can and can't split apart. Yeah, can't split apart a difference, subtraction in the middle, can't split apart a sum. Okay? That may come up here as we go along, or in the homework anyway. Okay. All right. Now, what I want to start now with is, again, we're going to talk simplifying radicals. But let's talk about our operations with radicals. We talked about polynomials. We multiplied them, we added them, we subtracted them. Well, we're going to do the same thing with radicals. We're going to add them, subtract them, and all that good sort of thing. For example, start out here with a 3 square root of 2 plus 4 square root of a 2. 3 square root of 2 plus 4 square root of 2. What I like to do is correlate this with going back to terms, variables, terms with variables in them. If I had 8x plus 9x, I can combine those. And I combine those because, why can I combine those, first of all? They have the same variable with the same power. They're like terms, yeah. I can combine these because, yeah, they are like terms. Meaning they have the same exact variable. The variable is exactly the same. X to the first, x to the first. Now, how do I combine them? I know that we've done this many, many times, but it makes a correlation, like I said, with the other. All right, we combine them by adding the numbers, right? And what happens to the? Stays the same. Okay. Well, very similar thing happens in the case that I have before you right here. notice here, what I've got is I've got radicals, and wouldn't you say these are like radicals? Yeah. When you're adding radical terms, just like when you're adding terms with variables, you want to look for like ones, like radicals. Now, what do you think like radicals will mean? Exactly the same root, number in the root, everything's the same about the radical. So in this case, yeah, we've got like radicals. Same number in the radical and the same root. So we have like radicals, just like we have like terms over there. Now, how do you think these will combine? Well, we're going to add the numbers in the front, right? 3 plus 4, 7. What happens to the radical? Stays the same. Yep. So yeah, it's very much exactly like adding like terms. Okay? So when we're adding radicals, that's what you want to look for. Like terms. Now, would the same thing go here? I'm subtracting. Same thing goes, doesn't it? When I subtract terms, I need to have like terms. When I subtract radicals to combine them, I need to have like radicals. So I do have like radicals. The root is the same there, square root of 3, square root of 3. So get it by doing the minus 15 minus 7 gives me 8, and the radical stays the same. So yeah, this one would simplify to 8 square root of 3. So it's a pretty simple process, just the same as we've had before. Okay, now what if I had a mixture there? Would I go ahead and combine those? Could not combine those, right? Because again, it's all about the like radicals. They're both square roots, but one of them's the square root of 2, the other's square root of 3. Okay? All right, just like having an x and a y instead of the radicals there. All right? Now, what about 9 square root of 5 minus 4 square root of 5 plus the square root of the 5? Well, can I combine these? Yep. All these combine because they are all square roots of 5. If you do them 2 by 2 here, these two, 9 minus 4 gives me 5 square root of 5. Then add to that the square root of 5. You can do it all at once if you want to, but what is that going to give you? Why is it 6 square root of 5? Yeah. There's not a number in front of it, but there is a 1 there, isn't there? There's an understood value of 1 there. And so, yeah, we do get 6 square root of 5. All right? Now, here's another word of caution. 3 plus 2 square root of 7. Very tempting to say that's 5 square root of 7. But is that 5 square root of 7? It's not 5 square root of 7, is it? This one, can't simplify this one either, can you? And yeah, it's all about the like radicals. That one has radical 7, square root of 7. This one doesn't. So even though those are just sitting there, you're just thinking those should be added together, they can't be added together because this would need a square root of 7 to add to that one that has a square root of 7. Okay? So yeah, that one's another one. Just leave it as is. Okay? All right, now, there are some others that are a little bit tricky. Square root of 24 plus the square root of 54. Can't combine those, obviously. However, yes, these can be each individually simplified, can't they? I can take the square root of 24 and I can simplify it using things we talked about previously. How could I simplify square root of 24? 12 and 2, well, 6 and 4, yeah. 6 and 4. Let's break it down as the square root of 4, square root of 6. 24 is 4 times 6, so square root of 4, square root of 6 is good because then you can break down 2 square root of 6. Same thing here I can do with 54. What can I do with 54? How about 9 and 6? Yeah, or 6 and 9. 9 times 6 is 54, so break it down to square root of 9, square root of 6. Square root of 9 is 3, square root of 6, square root of 6. So now I have 2 square root of 6 plus 3 square root of 6. Aha! We've got something we can add, right? What do we get there? 5 square root of 6. Add the 2 and the 3, square root of 6. Okay? All right. Two square root of 200 minus 6 square root of 50 plus 3 square root 48. Nice long radical problem there. But again, what do you see? Break down the square roots, right? The square root of 200 can be simplified. A number of ways. Hopefully, one way you can see that is 100 is a factor of 200. Yeah, I can break that 200 up as 100 times 2, so it'd be square root of 100 times square root of 2. What about 50? 25 and 2. So that minus 6, and break down the square root of 50 is 25 and 2. And then 48. (16 and 3). 16 and 3. So it'd be plus 3, and then square root of 16, square root of 3. On 48, 24 and 2, well, what I'm looking for is this one that I can break down, right? So if I went with 24 and 2, neither one of those is square root. Square root of 24, square root of 2. Yeah, okay. Now you could do 4 and 12 for 48. But the thing is, you're going to have to break down the 12, which is fine. You can still go through that and do that. But take another step. Okay? So what have I got here? 2 and then 10, and that'll be times 10 times the square root of 2, and this will be minus 6 times 5 square root of 2, and then this will be 3 times 4 square root of 3. With me on that? So look at this. I've got 20 square root of 2 minus 30 square root of 2 plus 12 square root of 3. With me on all that? So what can I combine, come to find out? The first two, yeah. I can combine these first two. Well, what about that third one? It's a different radical, isn't it? It's square root of 3, so it's just the first two. 10 minus 20 minus 30 is negative 10, square root of 2, and then that last one, well, we can't combine it with the others because it's a different radical. Okay? Question or concern about adding and subtracting radicals? Okay?